Okay, now then, we're going to turn the page and we're going to talk about solving systems using Cramer's rule. So right now, at your disposal, you have substitution, elimination, the inverse method, and now we're going to talk about Cramer's rule, which is another way to solve a system of equations. And it actually can be quite useful. There are some people who do Cramer's rule all the time. They never substitute or eliminate. We'll talk about why that might be here in a second. So here's the problem. And here's how we're going to do it if we're using Cramer's rule. So remember, you got to show your work. So what work do you show? Well, step one, find the determinant of the coefficients. So here's my coefficient matrix. 3, negative 7, 2, 1. I line them up. They got to be lined up. Make sure x's and y's are lined up. So 3, negative 7, 2, 1. We're going to find that determinant. So we multiply, get 3. Multiply, get negative 14. But we subtract, so the determinant is 17. Is everybody with me so far? Okay. That, believe it or not, remember, we're solving this system, so our ultimate answer is going to be an x and a y, an ordered pair. Believe it or not, x and y are fractions, and their denominator is 17. So that coefficient determinant gives you the denominator of both of your variables. All right, so what about the numerators? Well, the numerators are actually other determinants. When you are finding the x numerator, I'm looking for the number that's going to go right in here, the x numerator. To find the x numerator, cut out the constants. Pretend you have a pair of scissors. Cut out the constants and paste them on top of the x numbers. When you're finding x, you paste these on top of x. So that determinant, if you can imagine that, cutting that out and pasting it here, that determinant is going to have a 9 and a negative 6, and then the negative 7 and the 1. I don't switch anything around. I literally cut and paste. And then to find y, I do exactly the same thing, only I paste this on the y's. So I have 3, 2, 9, negative 6. Now, even if you don't care about this, just pause for a moment. Aren't you awed by the guy that was smart enough to figure this out? I mean, this is incredible. This is incredible. All right, so now we're going to evaluate those determinants. So we multiply and get 9. We multiply and get 42. And then we subtract. So what is that? Negative 33. Multiply, get negative 18. Multiply, get 18. But we're subtracting, so that's going to be negative 36. And that's the answer to the question, right there. Now, let's talk a minute about why somebody might choose to do Cramer's rule instead of eliminate or substitute. Because we could have eliminated or substituted on that problem. Can anybody think what would be advantageous about this? Well, stop and think about the steps for substitution and elimination. I would, because I'm an eliminator, I would have eliminated, and I would have multiplied through by 7 and canceled out the y's. And I would have solved and got x right here as my answer. What would I have to do next then, once I got negative 33/17 as my x value? Oh yes, I would have the joy of plugging negative 33/17 into one of these equations and figuring out what y is. Now, we can do that, but what a hassle it is to deal with those fractions. Notice that in Cramer's rule, there is no potential of having to work with fractions. Every math operation in that problem is either multiplying integers or subtracting integers. You can do all that in your head and you can do it pretty quickly. So let's try the next one. When we eventually have a test over all this, or maybe we'll even have a quiz before that, you will have to know how to use Cramer's rule. So let's practice this seriously. Problem 3B. I'll write down the problem. All right, who remembers step 1? What do I do first?
Find the determinants of the code.
Exactly. Now, on the off chance that this determinant, oh, this is going to be an easier one. We're going to like this one. On the off chance that that determinant turns out to be 0, that would immediately tell you that there's no unique solution to this problem. So if that would happen, you would have to go back to substitution or elimination to figure out if there was a solution or if there were infinitely many solutions. But since this number is going to become my denominator, if that would happen to be 0, then I'm done with this procedure because I can't divide by 0. Ours isn't, it's -1. All right, who remembers the next step?
Yeah, copy and paste.
Cut and paste. We love it. We're gonna cut and paste the -7 and 1. And for x, we'll put it right here in the x column, which is -7, +1. And so that'll go here, and so I'll still have my 2 and my 1 here. And then for y, I'll put it over here, so I have my 5 and my 3 and my -7 and my 1. Please do not rearrange. Physically, cut it out, paste it on, and that's the order everything stays. Cut it out, paste it on, and that's the order that everything stays. All right, now what do they got? -7 minus 2, or -9. And 5 minus -21, or 26. So I would probably write my final answer as 9, -26. Any question about that? Okay. Well, shoot. Now we're going to do another procedure, a new procedure called Gauss-Jordan reduction. And we're going to do it. Yes.
Is this lunch period?
We're going to have lunch, but when we're virtual, we do it at the end.
Okay, I didn't know that.
Yeah, well, it just wastes too much time having everybody check back in, taking attendance, all that crap. So, yeah, I know it's the lunch period, but we're not going to stop and come back. We're going to stop and you're going to be done, okay? But not yet. We're not stopping yet. Now we are going to do a new procedure called Gauss-Jordan reduction. Now, again, because it's totally on the calculator, there isn't much to write down. But this time, I want you to write down this matrix for problem A. This is the matrix that we're going to be putting into our calculator. You will notice that I am not, basically, I'm putting in every number in the problem. I'm not putting in any letters. although this column represents X, this Y, this Z equals, and these are my constants over here. So this is a little different than what I did with the inverse method. With the inverse method, I put in two matrices. Here I'm putting in one big matrix. All right, everybody okay? We're going to let the calculator do some work, and it's going to spit out another matrix, and that is going to give us the answer to the question, the X, Y, and Z that are going to be the answer to the question. So that's all you have to write down. Now we're going to fill this in after we do it. But you write down the matrix that you're putting in, you write down the matrix that comes out, and you write down your answer from that. So here we go. Second matrix, over to edit, enter, or so you let this be A. Now be careful, what are the dimensions of this guy?
3 by
3 by 4.
Yep, so 3, enter, 4, enter. You may not be able to see the whole matrix on your screen. Don't worry about it. It's all there. Your calculator will take care of it. So here we go. 1, 1, negative 1, 2, and then so on. Are both those 14, or did I copy that wrong? Okay. All right, as always, as soon as you get it in, you're going to quit out of there. Everybody ready? All right, here we go. Back into second matrix. But for the first time, we're actually going to let the calculator do some math now. So go over to the math, and then click all the way down. It's a long way down there. There's a lot of matrix math, tons of matrix math. We're going to go all the way down to the button that says RREF. When we do the Gauss-Jordan procedure, which we could do by hand, but it would take 15 minutes. Used to do it in the old days. That's how I learned it. But when we do the Gauss-Jordan reduction, our matrix is going to be in reduced row echelon form. That's what RREF stands for. So Gauss-Jordan is the process that puts the matrix into this form. So go down to RREF and hit enter. So it should show up on your home screen now, RREF. With a parentheses, we're going to put matrix A in that parentheses. So second matrix, enter. And now your screen should say RREF A. Press enter again. And it is going to give us the reduced row echelon matrix. So 1, 0, 0, 4, 0, 1, 0, 0, 0, 0, 1, 2.
Mrs. Ford,
Yes.
so do we need to close the parentheses, or do we just
No,
leave it open?
you don't need to. You can, it won't hurt anything to close it. In general, if there's nothing coming after it, you don't need to worry about closing it. But if you're worried about that, just always close it. It won't hurt anything. Now, I want you to notice something. The matrix that you put in, kids, this was the X column, the Y column, the Z column. That hasn't changed. And these represented equations. So it was 1X, 1Y, minus Z equals 2. Well, what does that top equation now say? 1X, no Y's, no Z's, equals 4. So guess what? X equals 4. That's what that equation says. What does the middle one say? Y equals 0 and Z equals 2. So the answer to the problem is 402. reduced row echelon form puts ones in these spots and all these zeros so that each variable is known. Right here, this is your answer, this column right here, 402. Isn't that the coolest thing ever? People, even in your sleepy state, your bored state, you have got to think this is pretty amazing, because it is. All right, let's try another one. Look at the next one. Grace Straley, this is so much fun. Maybe we ought to just skip lunch today. Keep going. All right, what do you notice about problem 4B? Please pay attention. There's something odd about it.
There's 4 variables.
4 variables and 4 equations. So it's going to be a bigger matrix we're going to set up. Our 4 variables are going to be x, y, z, and w. And then, of course, we're still going to have the equals number thing over here. So 1x, 1y, minus z, no w's, equals 4. No x, 1y, no z's, 1w, negative 4. 1x, negative 1y, no z's, no w's, 1. 1x, no y's, 1z, 1w, 1. Now, the order of the variables is not important, but obviously they have to be lined up. So some people like to put their variables in alphabetical order, so they might have put their w first, and that would be okay. It would be a different matrix. But what you need to remember is the order that you put them in here is the order that they're going to come out. So my variables are going to be x, y, z, and w. That's how they're going to come out, because that's the order that I arranged my equations. Alrighty? So here we go. We're going to put this matrix in. We're going to press our magic RREF button, and a new matrix is going to come out that hopefully is going to give me my answer. Here we go. What are the dimensions of this one, by the way?
4 by 5.
Yep, thank you. Now the matrix that comes out is going to be in reduced row echelon form. And ideally, we're going to get our answers, which we do. Nothing wrong with these, but if you want to make them fractions, go ahead and math frac it, and you will get your fractions. All right, did anybody not get that? Is everybody okay? Okay. All right, I'm going to set you loose on the next one on your own. Remember, one more thing, guys. This is what you have to write down. So when you are assessed over this, whether it's homework or test or quiz, you got to write down the matrix that goes in, indicate that that's the operation you're using, and this is the matrix that comes out. And then in the answer blank, you can put your answer. Okay? So let's go ahead and try the next one. Oh, cruddo. Unless I type something in wrong, I got something very weird happening here. Did anybody else get this for the matrix that came out? Oh yeah, there's Jesus got his hand up. Okay, this is odd, kids. Remember, the last couple that we've done, and I don't even remember exactly what it was, but the bottom row looks something like this. And that told us that z equaled 3. What does this bottom row say? Well, let's look specifically at z. It says 0z equals 0. Like this one said 1z equals 3. This says 0z equals 0. Well, wait a minute. If 0z equals 0, what could z be?
Any number.
Any number.
Could be 0.
Any number. It could be 0, but it could also be 10 or root 17 or anything. So when this happens, guys, when this happens, you start by saying, all right, z can be anything. And we express that simply by saying z is z. That's an identity. 5 equals 5, 8 equals 8, 12 equals 12. So z is z. Now we're going to back up an equation, and we're going to see what this says. Remember, your columns are x, y, z, and equals. So this middle equation says y plus 3z equals negative 13. Y plus 3z equals negative 13. Does that make sense to everybody? Which means y equals negative 13 minus 3z. Now, that is the best I can do because I don't know what z is. If I knew that z was 6, then I could find a y value. But that y value would be different if z were 4. So I can't do anything except write it this way. All right, so z is z. Y is negative 13 minus 3z. Now go all the way to the top. That equation says x minus 4z equals 23, which means x equals 23 plus 4z. And again, if you give me a z value, I can come up with an x value. But it's going to keep changing depending on the z. So, how do I write this answer? Well, the general form of the answer, what we call the general form of the answer, x, y, z. Now, I want you to notice that x has two parts. It has a number part and a z part. So I'm going to set up my answer to reflect that. So x is 23 plus 4 z's. So there's just a plain number column for my x, y's, and z's, and then there is a z component. So for x, it's 23 and 4. For y, it's negative 13 and negative 3. Now, don't be confused. What is it for z? What is the number component up there? 0 and 1z. Z equals 0 plus 1z. So z equals z. This is your general solution. I said form, I probably should have said solution. This is your general solution. It's the general form of the solution. So this describes every answer. If you want a particular solution, Then you're going to pick a value for z. The easiest value of z to pick is 0. Because if you let z be 0, then your point is going to be 23, negative 13, and 0. But there are infinitely many particular solutions, infinitely many. So you could pick 1, and then you do 23 plus 4, so that would be 27. Negative 13 minus 3, that'd be negative 16. I'm letting z be 1, if z is 1. And 0 plus 1, that would be 1. So there would be another particular solution. There are infinitely many of them, and they are found by simply letting z equal a number.
I have a question.
Yep.
So when we're doing like a quiz or something like that, and we have to find a particular solution, in order to get full credit, we have to find both.
Oh no, you find one. It'll say find a particular solution.
Okay.
There are infinitely many. So there's nothing special about these two. This is the easiest one to find because there's no math involved, but there are infinitely many particular solutions. Okay? They're a teacher's nightmare because each of you could come up with different ones, right? It's crazy. Now, I do want to mention one more thing, and then I'm going to let you go to lunch because Grace is giving me the evil eye. Really, she's not. She's smiling. She's a sweetheart. But remember the first problem we did? It looks like this. I erased the problem, but it had 3 equations, 3 unknowns, looked just like this. And I said the answer that you found was the point where those 3 planes came together, like the corner of the room. You got an answer like this, just a particular point, 1 point. Well, what's happening here is we still have 3 planes, but they're not coming together in a point, they're coming together in a line. So it's like having, this is hard since I don't know what you can see there, but it's like having, okay, I got this piece of paper and this piece of paper, and then I have another piece of paper, and they're all meeting right there in a line, like right there. They're all coming together right there. That's what's happening in this situation. When you do Gauss-Jordan reduction, the only other thing that can happen, this one was out of the ordinary because the bottom row went to all zeros. When the bottom row goes to all zeros, this is what you got. You've got infinitely many solutions, and you have to express them in the general form. Now, the only other thing that can happen is you can end up with this. So 0, 0, 0, 1. That says 0z equals 1, which means there is no solution. Because 0z's cannot equal anything but 0. So the best thing that can happen on the bottom row, you get this. That's the best thing that can happen. That tells you z equals 1, or you get a number there, z equals 4. If it's all zeros, then you're going to have this mess right here. If it's all zeros except the last number's a 1, and this is all coming from the bottom row, in reduced row echelon form, it won't happen anywhere else. Your bottom row will tell you the story. If it says 0, 0, 0 equals 1, that's no solution. Okay? That's a lot. That's a lot. All right, you guys, I would suggest, now some of you have already taken the quest. I sent a thing or put an update or somehow I communicated to you that if you're not happy with that grade, you've already taken it, you're free to take it again because we're going to take class time to take it. So the first part of the period, we'll be doing that quest. Those of you that haven't taken it yet or are going to retake it, it's been forever since we talked about the law sines and cosines. It's easy, but I would definitely suggest that you go back and review those review videos that are in the Chapter 5 Schoology folder. Okay? Everybody clear on that? All right. God bless you all. Have an absolutely wonderful Easter.
Thank you.
Thank you.
Bye-bye.
Thank you.
Bye.
Thank you.
Bye. George, wake up.
It's cool for the where it's like true and false for like a computer where one is true, zero is false.
Awesome.
So, have a good Easter.
You too, bye-bye. Oh, George.